Hello, and welcome to today's special webinar event on strategies to hurdle the last mile of AI and get into production faster. Today's webinar is sponsored by Hewlett-Packard Enterprise and NVIDIA and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media. I'm excited to be your moderator for this special event. Now, before we get to today's great content, there are a few things you should know about this webinar. First off, we want this to be a valuable educational event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. Second, I'd like to bring your attention to some valuable resources in the handouts section of your webinar control panel. There's a link to a site for getting started with NVIDIA and HPE. There's an IDC report on the worldwide artificial intelligence market for IT services. There's an NVIDIA fact sheet on certified HPE systems, an NVIDIA paper on the industrialization of AI, and there's a PDF from HPE about operationalizing enterprise AI. So a lot of fantastic resources today. I encourage you to download those handouts now and share them with your friends and colleagues. Third, at the end of this event, we'll be awarding a $300 Amazon gift card to one lucky attendee on the live event. If you're watching this webinar on demand, I'm sorry the drawing has already occurred. But if you are the winner, you can choose to donate the value of that gift card to one of our selected charities. Thanks to generous prize winners on previous Actual Tech Media events, thousands of dollars have been donated to charity, so thank you in advance if you make that choice today. The official terms and conditions of today's prize drawing can be found at actualtechmedia.com. Scroll to the bottom and you'll find the prize terms and conditions links there. Finally, one of the best benefits of this event is the opportunity to ask questions of our expert presenters. So to help encourage you to ask a question, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions, pick out the very best one, and contact that prize winner. And with that, let's get to today's discussion. So we're going to start with a conversation about getting AI projects from idea or even from proof of concept to production. So joining us for this conversation are two absolute experts in AI who also hold executive positions that give them a comprehensive view of the challenges and solutions for bringing AI projects across the finish line in enterprises around the world. So I'm honored to bring on our speakers. We have Soren Karan, who is Vice President and Fellow at HPE in the Artificial Intelligence Strategy and Solutions Group. And we have Mark Hamilton, Vice President of Solutions Architecture and Engineering at NVIDIA. So these are two senior executives at the center of the action worldwide in enterprise AI projects. Very exciting conversation. Let's get to it.
Let's just start off with a question that's on so many of our audience members' minds. Why do so many AI projects fail to get out of the lab? Mark, let me turn that to you first.
Sure, Scott, that's a great question. Today AI now has been around for a while, and I think anyone graduating from university today, they've taken a couple of AI classes, right? And they can go in and set up a system, train an AI program, and get some interesting results. And that's what happened in the early days of AI, right? Early AI problems were really consumer-facing internet services. What movie do you pick? What sort of shoes should you buy? And there, the cost of making a mistake was very low. Right? Today's AI problems in the enterprise, the cost of making mistakes can be really high, can damage the business, damage property, damage an individual. Right? And so the accuracy of those sorts of AI systems is important. And of course, accuracy is often directly related to how much data you have. So one is having that scalability. Second is, AI, because it started in the cloud, AI typically works best in cloud native environments. Now, every CIO, every data center is trying to implement cloud native infrastructure. But those are new sets of tools for most companies, and they need help going with that. So those are just a couple of things from my side.
Soren, any thoughts on that?
Yeah, thanks, Mark, for that. We actually do see that a lot as well. What I wanted to add is that, as Mark said, starting a POC is rather simple, right? And we see a lot of customers that are basically downloading. They have some data in a place. They download a ready-made model, and once that model is downloaded, basically they start on the data. And as Mark said, you can get some good accuracy, which will say, "Fantastic, this works." What happens next is that basically then they need to take that and actually either train that at scale and take this to an accuracy, as Mark said, just to make sure that it actually delivers what it's supposed to deliver. And this is where the problem begins, because I'm not actually having the data and, let's say, one model somewhere close together on a storage device and some accelerators and some GPUs, and magically it works. But I need to do that for multiple users. I need to do that for across my businesses. I need to do that across my groups. And even more so then, in order to actually get that outcome that everybody wants to get, I need then to airlift this and put it in an existing business process, in an existing business operations. And this becomes, again, very challenging, because nobody has a business process which is actually greenfield. Everything is brownfield. The way they ingest the data, the way they then move the data from wherever it is generated to a place where the model can analyze it and so on. So basically, it's moving from POC to production has a lot of problems: the technical problem, the operational problem, the data problem in itself. How do I get the data back to the model, and so on? So it's not as straightforward as driving a POC. Everybody drives POC. Most of them are, let's say, successful, but then everybody's asking themselves, most of our customers are asking themselves, what next? And then this is not easy, right? Because you need the scale in the data center to get a very good model, but then to redeploy this back at the edge, where in most cases, everything is a brownfield and you need to put things together.
Great observations. Let's turn to how you're seeing organizations benefit from AI at the edge. And Soren, let me kick that to you first.
Thank you, Scott. So obviously, I'll start with one of the use case which is on everybody's lips, simply because either they have seen it on the street or they have actually heard people talking about it, which is this idea of autonomous driving in automotive, for example, right, in transportation, where we already see on the streets today cars with all sorts of cameras on top, or all sorts of sensors that are actually preparing us for a future when cars are going to be connected, autonomous, shared, electrified, and whatever not, right? So this is one of the first use case, which is actually very difficult to crack, right? There are some companies which are close to actually getting it, but we've been promised for some times now that soon where actually everything is going to be autonomous driving, but there is still a bit to go. And so that is simply in transportation, right? We know that it's coming, and it will impact everything. It will impact our lives. It will impact cities, and so on. Another one that I actually wanted to look at is obviously manufacturing, because we are actually seeing a lot more customers adding quality inspection, adding on their assembly lines, or adding worker security, worker safety and security, or looking at predictive maintenance, and so on and so forth. So manufacturing is yet another industry that are actually seeing moving very, very fast. And obviously there is smart cities. We're actually seeing, as I was saying, traffic management and smart utilities and smart lighting and smart transportation, and so on and so forth. So we are actually seeing this across, and I will ask Mark to complete with other industries that they are seeing as well.
Sure, I'll take a slightly different view, right? Soren talked about a lot of sort of AI applications really based on computer vision, right? And computer vision is one field that in the last decade has been totally changed by AI. No one is doing traditional computer vision today. If you're at the end of an assembly line, a healthcare instrument, that camera in the retail store, those are all great examples of using AI for computer vision. But really, we see today industries advancing into two new types of use cases for AI. The first is recommender systems. Right. Again, we've all experienced a recommender system if we bought something online, saying you should buy something else. But if you think about it, early recommender systems, and here I'll jump into a little bit technical, right? We're based on simple data analytics algorithms, k-means, XGBoost, those sorts of functions that any data scientist for the last decade has used. And those get you to a certain level of accuracy, right? Good enough for a simple recommendation where the cost of making a mistake was low. But 80% accuracy when you're picking a movie is maybe pretty good. 80% accuracy when you're making a financial decision for your company, very bad. So to get further along, you really need a deep learning based recommender system. And again, we've really seen the emergence of these today across many different industries. The second is conversational AI. If you think about it, every industry has a call center. Every industry interacts with customers in spoken and in written form. Think of a financial services institution. All of the call center records they have from when you call your bank, and all of the written data, contractual data isn't just in a preset form. It's contracts, it's legal work. And in conversational AI and natural language processing has really emerged since about 2018 with the emergence of a new class of deep neural network problems called transformers. The challenge with transformers is, again, that scale. Transformers today, GPT-3 was one of the earliest large-scale transformers, 175 billion parameters. Microsoft and NVIDIA just this week announced Megatron Tensor. Megatron has over 200 billion parameters in the model. And we see data scientists today working on problems that will soon get to 1 trillion parameters. So that scale problem brings you amazing new results. But again, it's a challenge of maintaining the model through the entire life cycle of the software.
Those numbers of parameters are just breathtaking. It's incredible where we are and where you're saying we're going. That's amazing.
Scott, one thing I wanted to add on that, you have the amount of parameters, I completely agree with Mark with the rise of NLP. But the thing is about the GPT is that is one of the first general purpose models that are actually releasing. The same model, once you're actually training it, and this is why the sheer size of it is able to do the same model, translation for multilingual, summarization, text generation, and so on and so forth, right? So we're actually seeing this rise of general purpose models that allow me, once you're actually training it, it allows you to do a multitude of tasks, right? Computer vision now is trailing behind while computer vision used to be ahead. And we are actually seeing this with our own customers is that the problem with GPT-3 is that not all the customers have actually ability to train this model. So what we're seeing also right now is the whole idea, and to tie to our discussion, is the model as a service, right? So once you have large customers that are training these models, because it takes years and, let's say weeks, months, and some years in some cases, depending on how many accelerators you have. Once they actually train this, they're putting this out there for across the industries, customers across the industries to train this as a service for a fee, right? Translation for a fee, summarization for a fee, and so on. So we are seeing this rise as well simply because of the sheer size of the general purpose models.
Excellent. Excellent. Thanks for that context. Let's go back to some of the topics that you originally highlighted. Can we take those and break them down further? And maybe you can comment on how HPE and NVIDIA are addressing those challenges. So let's start with the topic. What do you mean by companies having a scalable strategy from edge to core to cloud? And how do you operationalize that? Soren?
Yeah, thank you for that, Scott. So sometimes I want to think about AI as a closed loop, right? And even if it is not actually all the time like this, I want to think about it as a closed loop. What do I mean? So normally the data is generated somehow at the edge. Not all the time it is generated in the data center as well, but in most of the cases, the data somehow relies outside of the data center, either on an edge device, which is somewhere outside of the data center, really close to where the data comes, or near edge, which is somewhere which is in a very small very small rack outside of the data center, and so on. So still data is generated there. What happens then, the data actually travels back, let's say in a rack outside of the data center where it's aggregated. From there, the data goes into the data center and it is actually transformed into models, right? So the moment it transforms into models, those models then go back either at the near edge in this rack outside of the data center in a retail store or in a manufacturing floor and so on, or directly at the edge to make predictions. So it starts at the edge, it travels all around, and then it goes back at the edge. So it is in most of the cases, right, in most of the cases, a closed loop. Now, I'm not saying that inference cannot be run or predictions cannot be delivered in the data center, or the training cannot actually happen at the edge. As you are going to see a bit later, it can. But in most of the cases, it is a closed loop. Now, what we normally see with customers is that in order to actually be able to put AI in production, you need to be able to control the loop, right? So you need to be able to control your entire pipeline, how data is being generated, how do you save the data, where, how do you then train your model at scale on hundreds of GPUs to make sure that you have that accuracy that Mark was talking about earlier, and then how back you're actually orchestrating your containers back onto the edge device or the near edge device and so on. So it is a skill problem because first you need scalability in the data center. You need to be able to design, to write your model on a laptop, for example, but then quickly train on thousands of GPUs or hundreds of GPUs. Think back to this very big size model. So it is scale, it is AI at HPC scales within the data center. But then you actually do have a problem from the point of view of scalability of the edge, where problem is twofold at least. First is if you are a very large enterprise that has a lot of edge devices, like a lot of sensor, a lot of manufacturing assembly lines, a lot of cameras in a retail store, or if you're a museum, for example, you have all of these edge devices that become a fleet and that they need to be managed. So it's the sheer scale of that. And then the other scale from the edge to the core is at the distance in between, right? Because normally the data needs to, as I was saying earlier, needs to actually move from the edge into the data center. So that can actually really stretch the ability of you, for example, to manage a data fabric, or for you to manage networking, or for you to manage the redeployment within the edge device and so on. So from the HPE perspective, we are looking to create this edge to core AI platform, edge to core to cloud AI platform, and we are looking at it from two perspectives. Looking at development and training at scale, and looking at edge AI at scale, so to speak. So because of this, we are actually, recently we did various acquisitions like Mapar that became Esmero Data Fabric, like Blue Data that became Esmero Container Platform, and so on and so forth. Like the recently announced Determined AI that actually enables me to really do training at HPC scales. And we are looking forward to working also closely with NVIDIA from the point of view of the edge management, fleet management, and so on and so forth. So in the end, it is an edge to core a scalable problem, and we are actually looking forward to help our customers in order to make sure that they control this MLOps craziness that has been playing out in the recent years. Mark?
So in NVIDIA, let me start off by saying NVIDIA is the only AI company that partners with every other AI company on the planet, right? Every cloud, every OEM, every edge device vendor. But I think our partnership with HPE is really unique. And they're one of the partners that I love working with the most. Again, because we complement each other so well. One of the things that NVIDIA has built over the years is a software repository we call NGC. NGC is where we put not only all of our GPU optimized containers, but also pre-trained models, training scripts, and even data examples there. And so we take all of our software that we work on, and of course that's not only NVIDIA software, but that's our partner software, tools like TensorFlow, PyTorch, and others. And every 30 days, we optimize those with the latest CUDA, the latest NVIDIA optimizations. We test them. And we test them not only on our GPUs, but we test them in collaboration with HPE. HPE sells so-called NVIDIA certified EGX servers. EGX is our brand for OEM server. So it's not a particular server, but it's all of HPE's GPU optimized servers like the Apollo line. But more importantly for the enterprise, HPE's standard servers like the DL380, typically the most commonly used server in the planet. Almost every enterprise data center has DL380s. That system is certified with NVIDIA DPUs for networking and NVIDIA GPUs against the entire NGC software repository every month. And that gives you that scalability. So you can know that you can run that software and it's going to be optimized in an HP data center, in an HP edge server, if you have some cloud components in the cloud, and even out into the mobile edge robotics, automotive, things driving, crawling, walking around, they'd have an NVIDIA GPU in them. So that's, I think, one aspect of scalability. The second is as you start to deploy applications, you're going to start to have issues, right? And you'd like to have enterprise support. You don't want to go to 18 different companies. Obviously, if it's an HPE component, right, their hardware, their software, they provide great support. But for all the NGC software hub, all of the software that's in there, if it ends up being a problem with our Triton inference server, we'll fix it. If it ends up being a problem with our optimized version of TensorFlow, we'll go ahead and fix that and provide enterprise support for it. Finally, our software is built to scale. NVIDIA runs the largest single AI supercomputer of any enterprise company on the planet. On the top 500 list of the world's fastest supercomputers, it's the 6th fastest supercomputer. No one working at any private company has access to a faster supercomputer. You have to work for one of 3 different governments, US, China, or Japan, to have access to a faster supercomputer. So using that system and 20,000 other GPUs across our own internal IT infrastructure, we test all of our software for scale, including testing on HPE servers, and really working together with HPE to bring you those solutions that scale all the way from cloud to edge.
Great. So, and a couple of times in the conversation now, the challenge of scheduling inferencing jobs has come up. Mark, can you expand a little bit on that challenge?
Sure. This is one of the big surprises, I think, from NVIDIA that most customers don't know, that our Triton inference server supports, of course, not only GPUs, but supports CPUs as well. And here's why, right? Most companies start off with simple AI applications, right? And they're not running many of them. So inferencing can be done on a CPU. And often companies have a lot of extra CPUs around it in their infrastructure. And so using the Triton inference server in our NGC software hub, you can get started, train on GPUs, and deploy or run inference on CPUs. But as you get more and more AI applications, of course, that cost and the number of CPUs that you need is going to increase. So you're going to want to start shifting as you grow in your volume of inference to save money, to save power, to save footprint in your data center. You're going to want to start shifting to GPU optimized servers. Second is you get more and more complicated AI models. Large natural language processing models often take several seconds to run inference on a CPU. If you're doing some overnight batch inference and you've got 1,000 CPUs, maybe running a second or 2 is fine. But if you want to do a real-time transcription, like you might see at the bottom of your video conferencing tool, or have a conversational AI application, a chatbot, no one wants to wait 2 seconds for it to respond. So again, that Triton inference server being able to start on CPUs and then also switch over seamlessly to GPUs, work with the load balancer and figure out how best to deploy your inference applications across your data center is super powerful. And Triton is also integrated and works with different HPE data management and scheduling tools.
Yeah, and that's so that's a good opportunity for Soren. What about on the HPE side? What's the view on scheduling inferencing jobs?
Yeah, thanks, Scott. So as we, both myself and Mark were mentioning earlier, once you're actually having a model, deploying and scheduling it becomes difficult because of various reasons. Either because the hardware infrastructure, it actually supports the CPU or the GPU is in a brownfield. I mean, in a networking that you cannot always reach, or because, for example, the network connections is intermittent, or from time to time, simply the management of the device is not possible. So the other idea is that not only that you need to deploy the model, but then obviously you need to re-maintain the model, redeploy the model, test the model again and over again. So suddenly the idea of model management or simply scheduling the first the first inference session, and then keeping actually the model all the time up to speed and retraining the model becomes difficult. So from that perspective, we have been looking at either you can use, for example, the Esmeralda container platform. You're saying if you want to manage to actually orchestrate your devices within the data center, but then you can actually stretch that, for example, to your edge devices. But in parallel to that, HP also has the Esmeralda MLOps that allows the entire lifecycle management of the model, including deploying the model at the edge, managing the model, and then redeploying, testing the model, and so on and so forth. So on top, not only that, but we are also looking, for example, once actually the model has been deployed on the device, and then obviously it keeps redeploying. It keeps delivering the predictions and the outcomes that the customer want. From time to time, obviously, you need to make sure that that model either doesn't drift or doesn't actually change accuracy, or simply that model doesn't doesn't decrease in accuracy, and so on. So from that perspective, we are looking at technology which is called, in our case, swarm learning, that actually enables not only that to keep the model in production, but taking into account that you're actually having all the edge devices that might be in very different places. It enables you to retrain the model at the edge, taking into account that you cannot actually send the data back home, taking into account of the security, the privacy, and so on and so forth. So swarm learning for us enables not only to keep the model in production, but also to retrain the model where it is, making the scheduling of inference jobs and keeping them into production a lot easier.
Yeah, and I really liked how HPE and NVIDIA are truly complementing each other with your approaches. Can we talk about a topic that you highlighted around managing edge deployments? So we often hear about challenges around deploying AI models to the far edge and data center edge, issues around latency of the model, how you update models and push those back out without disrupting the current edge AI, and life cycle management, security. So, for Mark, with NVIDIA, how are you helping customers overcome these challenges?
That's a great question, and let me talk about that, and talk about that also in the context of partnership with HPE. Remember, we're a technology platform company, so we do a lot of things at the low level of the platform that NVIDIA is really best suited to do, and then we let HPE and others build on top of that, right? And so a great example is TensorRT. TensorRT is our inferencing optimization engine. TensorRT takes the output of your AI training, right? Your data scientist develops the AI model, then TensorRT starts from the developed model and it optimizes it for the specific GPU. It knows what sort of GPU or what sort of even CPU you're running on, and it will optimize, or think about it, compiling that AI program for the specific GPU. Again, something that NVIDIA is uniquely suited to do. A second piece of software is Fleet Command. Now, again, Soren talked about Esmeralda, which is one of HPE's Kubernetes-based management tools. Kubernetes is complicated enough to manage in the data center, where you typically have 3 or more Kubernetes management servers. But think about that, in a cloud-native environment, you want to take all of that goodness of Kubernetes and deploy that out on a low-end server with a small GPU, sitting out in a manufacturing floor, sitting in a hospital, sitting in a retail store, and you can't afford to send out an IT team there when the system goes down. So Fleet Command is an end-to-end control plane for managing the deployment of edge devices. A very simple sort of analogy of what Fleet Command does is, think about it. If you buy a web-based security camera, right, for your front door, right, you sort of plug it in, you drag and drop from a website, and boom, it's up and running, right? And if that camera goes down, the website is able to restart it, etc. Fleet Command does that for edge deployments. But there's a few unique things when you go out of the data center, right? Because you lose all of that control. You're not behind a firewall. You don't always have the physical security, and the communication paths can't always be trusted. So one, of course, all of the containers need to be encrypted. All of that data flowing out to the edge needs to be encrypted. Not only encrypted in flow, but encrypted out on the edge device, right? If a disgruntled employee walks away with a server from the small retail store, you don't want them walking away with your data. Second of all, of course, that container needs to be signed. It needs to be cryptographically identified as really coming from the right source. Otherwise, some hacker could go in and download, software that you don't want onto your edge device. So Fleet Command as a control plane manages all of that for the data center operator, for the edge operator, and then through APIs interfaces with higher level management tools, be it Esmorel or other HPE tools. So just some of the examples of how we're helping with these challenges together with HPE.
That's great. Thank you, Mark. And Soren, how is HPE tackling these challenges?
So, yeah, thank you, Mark. That was almost complete. So, but what I would like to add is, yes, we are partnering tightly with NVIDIA, and NVIDIA is powering some of our edge devices, let it be our AL1000 or ProLiant or DL ProLiant, where basically those becomes the tip of the spear that customers are using at the edge, or in some cases, you say the data center edge as well. What I want to end up with, and yes, we are using all the technology that Mark is reference to, the Triton inference for our servers, the TensorRTs of the world, and so on and so forth. So we are definitely using that, and we are partnering with NVIDIA to manage that with customers. But I wanted to end up here, Scott, with one example. So the way we're actually helping customers, and I'm looking at the four bullet points that you have here, is by the easiest way, the simplest way is to partner with the customer across the entire journey from the edge to the data center and then back at the edge. And one example that I want to take here is, for example, we're partnering closely with NVIDIA and with some autonomous driving companies across the world, where basically they do have everything that they're actually having here on the screen, meaning they are actually running, they are getting the data in the car, then from the car, the data actually goes back into the data center, from the data center, into a ingestion station, from the ingestion station into the data center. There they have a data lake, there you have the accelerators and so on and so forth. So you have really the end-to-end cycle. Now, what we definitely do with this type of customers, we are partnering with them from the point of view of managing the entire infrastructure, not only the infrastructure, but also the entire platform on top. So we are partnering from the as a server perspective via our GreenLake offering, and we are partnering with them at every stage, including gathering the data in the car, ingesting the data, bringing the data back in the data center, and then going back and managing the models, deploying the model, and so on and so forth. Even if they are using across the floor technology, most of them obviously powered by NVIDIA as well. So basically, we are partnering with them based on a service level agreement where they need to be all the time on the production. They don't need to have issues with the latency. They need to keep those models in production over and over again. And they have various partnerships around edge labs, and so on. So basically, we are taking care of the lifecycle management and security across the floor and delivering everything via our GreenLake services to our customers. And obviously, we are doing this by partnering with NVIDIA as well.
Great. And before we get to audience questions, I just wanted to give each of you, an opportunity for, some final thoughts here, in this section. Mark, I'll turn it over to you first.
It's still early days of AI in the enterprise. And I think what every CIO is looking for every project leader is looking for, is really looking for who's that trusted partner that I can team with. And again, I think between HPE and NVIDIA, we've got thousands of employees around the world focused only on helping our customers, right? And if there's a hard problem that our field engineers can't solve, we've got the experts back at headquarters, and they're more than happy to engage through HPE in helping you solve your problems.
Great. And Soren, any final thoughts?
Just take the first step. Basically, I know that everybody was jumping on AI 3 or 4 years ago, and then we suddenly seen a decrease of AI into production, as you were mentioning at the beginning of the call. but with the right partnerships and with the right people behind it, and with the right advice, definitely every enterprise should actually take the first step and at least deliver one successful AI model into production. Thank you.
Excellent. Thanks, gentlemen. That was a fantastic discussion. I know I learned a lot, and I'm sure the audience did as well. And now let's take some time for some audience questions.
Yeah, and so and just before we get to those questions, we've had several really good ones roll in already. But while you're entering your questions in the Q&A panel there, we do have a poll question for you. It's up here. What are the next steps HPE and NVIDIA can help you with on your AI ML journey? So I'll just leave that up there for the moment. And as you answer that one, we'll start on the Q&A. So Serene, Mark, are you ready for some questions?
I am.
For sure, Scott.
Okay, great. Super. Well, let me ask one that came in from Neil. He says, I've never figured this out. If I have a horde of edge devices transmitting their data to the mothership, where the big models run, then sent back out to the edge, aren't the communication costs prohibitive?
Well, this is Mark. I'll go ahead and jump in.
Okay, great.
Communication costs are really one of the things that you want to architect carefully when deploying at the edge. And that's why it's important to have an architecture that scales all the way from your data center out to the edge. By deploying NVIDIA GPUs and HPE servers, you can run in your data center, and then you can deploy that same GPU architecture, the same software out at the edge, and break up your problem into different parts. Do some of the filtering, some of the AI at the edge for things like real-time applications, or where you need to get an immediate predictive response, and then send back summary data and do longer-term batch type of inference or other retraining applications back in your data center.
So, thank you, Mark. So what I will add on that is that this normally happens a lot. We've seen this in customers a lot, but this also comes to say that normally it is more important to have a data pipeline and a data strategy being settled first before you actually go out and design and deploy your AI models at the edge. Because if your data pipeline was proper and your data strategy was properly designed and implemented and thought about, then basically you're actually thinking, as Mark said, which data actually stays at the edge, which data then is actually being pushed back, the corner cases or whatever you need. And then not only that, but as you're actually retraining at the edge on whatever data had to be sent, when you're redeploying models, you're not actually redeploying, for example, full containers or whatever not, but you're actually redeploying simply models because you have the right containerization at the edge. And this is this is a place where definitely NVIDIA and HP can help. So it starts with the data strategy, with the data pipeline, and the correct design and implementation of that strategy, and then obviously it finishes with how do you basically implement on top of that your AI end-to-end models and pipelines.
Okay, super. Next question comes from Steve, and Steve asks, we can clearly see how AI has enhanced business to consumer purchasing decisions. How do you see AI affecting business to business transactions? And let me kick that to Mark first, because Mark, you had mentioned in our conversation earlier about how much more accurate things need to be when you're doing, financial transactions versus movie recommendations. So what do you think about Steve's question there?
Well, it's a great question that Steve had. And fundamentally, the underlying architectures are exactly the same. But as I mentioned in the talk, right, if you're making a recommendation about what shoes to purchase or what video you want to watch, the cost of making a mistake is a lot lower. If you're making a $100,000 or multi-million-dollar purchase decision, and that's being driven by AI, it's important to know that accuracy is going to be higher and that you have a higher level of certainty in the recommendations that are being made to drive the decision. And that requires you to have often more data for doing training and using more advanced AI deep learning types of applications.
Yeah, and Sorian, anything you want to add about about how you see AI affecting business-to-business transactions?
So, based on what Mark said, so basically we are seeing in our day-to-day life, obviously as end consumers of technology, we do somehow interface with AI, even if we don't know about it. But more in the past, I would say 18 to 24 months, we have actually seen companies implementing AI models when they are actually working with other companies. So, for example, where you have fintech companies that are actually implementing AI to understand predictive measurements and to understand exactly how the market is going to move or whatever other else, and then making recommendations to banks, to FSI companies, and so on and so forth. So basically, within the last 18 to 24 months, since AI has become of age, we are actually seeing a lot more companies from the B2B perspective implementing AI either internally within their processes, but even more importantly, these companies have actually customers which they are actually serving using AI methods and AI tools. In the past, it was basically which camera am I supposed to use? How do I recognize a certain whatever image? How do I recognize a certain face? And then based on that, actually making some decisions at the edge in the data center and so on. Now more and more, we are actually, because AI has become on edge, we are actually seeing companies implementing AI as a service or simply delivering AI services to other companies. And with the rise of, as we were saying earlier in the discussion, with the rise of GPT-3 and other models, we are seeing, for example, summarization as a service or translation as a service, and so on and so forth. Simply companies providing other companies AI services. And this is something that we are seeing actually across the board. And this is actually going to grow as these very large and very big complex models are going to become available, simply because not everybody is going to be able to train and use these models. They are going to use other companies that are training and using these models and then consume AI to make their own decisions. So yes, AI is becoming an exchange basically between B2B, but also is becoming a service that other companies are actually delivering to their customers.
Sorry, let's stay with you for a second on, how much inference does happen at the edge versus the data center? What are the trends that you're seeing among, the latest deployments with your customers?
So initially, everybody, whenever we talk about AI, right, you have the training and the inference, right? So normally, and then people have actually come up with various namings and various things for training and inference predictions or developing and training a model in the data center, but still. So development and training, normally, everybody thinks that is actually happening all the time in the data center, while inference is actually happening all the time at the edge. What we are seeing today, and definitely this trend is actually going to grow in the next couple of years. If you're listening to analysts, to various type of analysts, and also if you are listening to our customers as well. But what we actually see today is that at least half, which is 50% of all the inference that is actually being run is actually being done at the edge, while the other 50% are done actually in the data center. Apologies, edge or near edge, so to speak, where actually data gets aggregated. So we're actually seeing a split. This is actually going to, in the next couple of years, this might shift a bit to the edge. So you might have 60 to 40%, but still most of the, at least 40% of the inference is still going to be done in the data center because of these large models. Because we might not have the power to actually go out or the capabilities to actually go out and still run all the models at the edge as inference, but also because, as I was saying earlier, you see this rise of inference as a service where customers, they just want to consume predictions. They don't care about actually buying or using the infrastructure or buying or using the model or building the model themselves. They just want to use this as a service. So we're going to see something between 60 and 40% within in the next couple of years. And the same thing, if you think about it, Scott, applies for training as well. Everybody thinks that most of the bigger models are actually done in the data center for training, right? Which, let's say it is true. But when you think about AI, it's not only about the next GPT-3 or the next supercomputer vision model, but it's also about machine learning and others. So including in training, we're actually seeing a lot of training done at the near edge, meaning in a rack somewhere outside of the data center, in a retail shop, in a manufacturing floor and so on, where machine learning models are actually being trained or retrained, so to speak. So even there, in the next years, we're going to see a division between something like close to 60-40% as well, right? Maybe a bit more in the data center. Deep learning, yes. Overall, machine learning AI is actually going to be done most likely at the near edge and so on and so forth. So the answer is between 40 and 60%, 40% at the data center, 60% at the edge. But it truly depends around the use case. And hopefully with NVIDIA for powerful accelerators, more stuff is actually going to be pushed at the edge. Let's see.
Okay. All right, great. And Mark, I want to kick that question to you as well, but I wonder if you might be able to bring in, where does the cloud fit into that too, as far as that, edge versus data center versus cloud in terms of, where you're seeing applications deployed right now?
Sure. I'll answer that two ways. The cloud way second. In the first way is to talk about the difference between batch and interactive inference. Let's say you're some sort of a daily newspaper and you want to update the feed for all of your readers overnight. You're going to go through and retrain your model nightly, and then you're going to want to re-inference each based on each user's profile. And that's a typical task that can be done in the data center because it's done overnight, it's not time sensitive, it's not interactive. But then when that user comes in, he reads their news feed and they want to go through and ask some interactive questions. That's much more likely to be done out on the edge because it needs to be done interactively. When you go beyond sort of typed or written question and answer and move to conversational AI, that provides even more of a challenge, right? You only have a few milliseconds to be able to provide an answer back, an inference back. Otherwise, the user is going to get distracted and isn't going to communicate with the chatbot or other service. So that's another great example. And finally, answering the cloud question, both of those two examples could be done in the cloud, in a central data center, or at the edge. Other types of applications, though, consider controlling a robot arm. That inference has to be done not only in very, very low latency, but it has to be very, very predictable. You can never afford to have a 1 second outage in communication out to the cloud. Same thing with driving a self-driving car. You never build a self-driving car architecture where all of the driving was being done in the cloud. It just doesn't make any sense because the car can't just stop and wait for communications to the cloud should you have a hiccup.
Okay, super. And maybe I'll kick this next one to Serene first, but it's sort of a related question from Elvira, who asks, would AI modules in the cloud be a way forward? Make it easy to tap into with an API or the cloud service? Are you seeing anything with AI modules like that?
So, Scott, apologies. Are AI models or modules? Models, I guess, right?
Modules, he said. Like verified AI modules in the cloud.
Okay. So, modules has obviously a lot of definitions, but yes. So, well, it depends what modules means. But basically, I do believe that customers, so whenever customers get started, and when I'm going to try to answer this because of the modules thing as wide as I can, and then Mark, please feel free to add. So basically, if we're thinking about modules like in tools that are actually going to be used, yes, we do see a lot of customers getting started in the cloud because it's easier to quickly create your tools, use your tools, and so on and so forth. But then, obviously, at one point in time, because of price performance per watt, because of cost, and so on and so forth, somehow whenever they actually want to truly scale, they move back into the data set, back on-prem or in a hybrid environment, or basically they are actually using both cloud, but also on-prem. whenever you're actually delivering things in production, I believe that moving onwards, we are going to be surrounded by AI models. With the rise of general purpose models or modules or tools and so on and so forth, I mean, models and then modules and then tools. Basically, I do believe that we are going to be surrounded by services. Do you want to basically do a summarization, go out and use it in the cloud? Do you want to write a piece of code that you don't actually want to write? No problem. Use an AI service that is actually going to do it for you. Do you want to? You are a hostel and you quickly want to use help for triage? That's fine. Use a service in the cloud. So I do believe that AI services are actually going to be the way forward as people and companies are consuming them. We are doing that every day. Every time you're doing something with your iPhone, most likely you're actually recognizing a face or whatever other else, you're actually doing it in the cloud most likely. So I believe moving onward, because of general purpose models, large models, and because we actually want to optimize the resources that are actually using or putting behind this our AI consumption, so to speak. AI services are going to be all around us, either in the form of models, in the form of modules like bigger and wider tools, and so on and so forth. So I believe from the development to usage and to inference and usage in the cloud and using it as a service, so to speak, either in a public cloud, in a private cloud, and so on and so forth, is the way we're actually going to see AI basically changing our world. Mark?
Okay. Yeah, fantastic, Mark.
Yeah, that was a great answer. The only thing that I would add is, again, if you architect your solution between training and inference, and always start by architecting it in a cloud native architecture using technologies like Kubernetes or other similar cloud native technologies. Then you can make the decision on a case by case basis. Do you want to deploy that service on-prem, in a colo, in a cloud, or in multiple clouds? If you go in and write to proprietary stacks, whether it's a cloud vendor's proprietary stack or a proprietary on-prem stack, then you really lose that freedom. So again, I wouldn't focus as much on your architecture about whether you're deploying on cloud or not. Just ensure that you're writing to a cloud native architecture such as Kubernetes. And then you can make that choice at deployment time based on security, privacy, cost, and other factors that may be involved.
Okay, super. Hey, and we've got time, I would say, for one more question. And while we answer that one, let me put up the final poll question that we have here about what additional information would you like about the HPE NVIDIA solution. But in this one, I'll pose to Mark first. But there's been a lot of discussion about the edge, and the edge is obviously the point where the data is coming in. Can you deploy two separate AI applications on the same HPE edge server?
Absolutely. In the early days, people were just trying out AI and they would deploy one application, and it wasn't uncommon to use an individual server per application. But today, AI is everywhere. And we find most enterprises want to adopt AI across every single enterprise application they have over the coming years. And so NVIDIA has a number of technologies to make that available. Certainly one thing is you can deploy more than one NVIDIA GPU and an HPE edge server and run one application per GPU. You can also go through and use products like our Triton Inference server to automatically load balance and schedule inference jobs, not only across multiple GPUs, but across different GPUs and CPUs across multiple servers. And finally, our Ampere GPU architecture with GPUs like our latest A30 and A100 GPUs. They support a technology called MAIC, or multi-instance GPU, which to the operating system makes a single GPU actually look like multiple instances of a GPU. And you can run different applications, different inference applications on each MAIC instance in that single GPU.
Okay, great. Yeah, and Serene, anything that you wanted to add on that?
No, I just want to close there, Scott. But what I wanted to say is that this comes to talk a lot about the tight partnership that we actually have. HP has actually with NVIDIA. And the one thing I want to add is that there is no recipe for this, right? So, meaning that depending on the customer's use case, you might want to run 1, 2, 3, 4, 5, 10 models and so on and so forth. So, what I would like to add at the end is that you have HP experts, NVIDIA experts ready to actually walk the customers through their use case. Why is it particular? What does it need, and so on and so forth, and actually get the right workload or use case optimized hardware and software stack that actually suits their needs. So we, both HP and NVIDIA, we are working closely together to actually deliver these platforms that enable customers to adopt and, as we were saying earlier, get their feet wet and actually just bring it into production.
Super. Well, Soren and Mark, thank you both for your time today and all your insights and for this excellent discussion. Really appreciated having this conversation with you guys.
Thank you, Scott. Thank you, everybody. Thanks, Mark, for being a great partner.
Great. Always a pleasure to work with HPE, Soren.
Thanks.
Okay, so before we wrap up, we have one more piece of business, and that is the $300 Amazon gift card. And the winner of the gift card is Victor Grado from California. So congratulations to Victor. We'll be in touch to get you your card. And with that, on behalf of the actual Tech Media team, I want to thank HPE and NVIDIA both for making this event possible. And I'd also like to thank you all for attending and for all your excellent questions. You guys really made this a great discussion as well. So that concludes today's event. Have a great rest of your day.